All right, my friends. So now we're going to look at the next two identities, which are the co-function identities and the even and odd function identities. Remember so sine and cosine are co-functions. Tan and cotangent, and secant and cosecant. All these are saying is that if we have sine of some angle, it equals to cosine of the complementary angle. So that's saying sine of 60 degrees is equal to cosine of 30 degrees. And we know that using our unit circle. We've seen that in the unit circle before because sine and cosine flip for 60 and 30 degrees. We can also use this in radians, saying sine of theta is equal to cosine of pi over 2 minus theta. So sine of pi over 6 is equal to cosine pi over 2 minus pi over 6, which is just 2 pi over 6, which is pi over 3, which is cosine of pi over 3, because pi over 6 and pi over 3 are complementary angles. So again, complementary angles are angles when they add up to 90 degrees or pi over 2 radian, and so they're co-functions and they're equal to each other. Why do we care? Why do we use this? Again, we're using this to evaluate specific trig functions. These rules help us manipulate trig functions so we can ultimately solve them and rewrite them. All right, and we also have the even and odd. That's just saying that sine of negative theta is equal to negative sine of theta. And as you guess it, since sine and cosecant are reciprocals, they're the same. So cosecant of negative theta is equal to negative cosecant of theta. This is the odd identity. Cosine of negative theta is just equal to cosine of theta. And secant of negative theta is equal to secant of theta because they're even. So odd, even. And tangent is odd. All right, let me clear this. This is a terrible eraser. Let's see if this one works better. Kind of does. Okay. You guys should see how I'm filming this. You would laugh like crazy. Okay. So again, why do we care? Why are we going to use this? Again, all of these identities are here so we can manipulate sine, cosine, tangent, so we can rewrite the functions and eventually solve the functions. That's our ultimate goal, is to solve trigonometric equations. All right, so if we know that tangent of theta is 1.28, and we want to find cotangent of theta minus pi over 2. Okay. Well, cotangent, like tangent, is an odd function. So we know that cotangent of theta minus pi over 2 is equal to cotangent of negative theta minus pi over 2. Which, if we take out the negative, we just get negative cotangent of pi over 2 minus theta. Which cotangent of pi over 2 minus theta is just tangent. So this is equal to negative tan of theta, which is negative 1.28. So there we used the even and odd identities, and then we used the fact that cotangent and tangent are complementary or cofunctions. Okay. Now what? Let's do one more. Okay. So if we want to do sine of x is negative 0.37, and we want to find cosine of x minus pi over 2. All right, well, let's first look at cosine. We know that cosine of x minus pi over 2 is equal to cosine of negative x minus pi over 2. If we take out the negative, we get negative cosine. Then x becomes negative and that becomes positive, so we have positive pi over 2 minus x, which again, now we're at our cofunction identities. We know that sine and cosine are cofunctions, so this is equal to negative sine of x, which would then just be 0.37. Right, so again, just other two identities that we can use to manipulate.